Okay, everyone take notes that our SAT2 we cannot carry out on next Tuesday because next Tuesday they have the orientation. So they are going to use our classroom. So next Tuesday it will be online. Okay, so our I'm muted. Noah? I'm not muted. This one is muted. I have to mute this one. Okay, you don't have to worry. This one is not muted. They can hear me. If they can't hear me, they will tell me. Okay, so you refresh it again. Okay. Okay, so this one I have to record so that, okay, it's because they are having their orientation next week. So we will keep our SAT on Wednesday. So SAT2, okay, 13, your wish come true, okay? But afterward that I haven't said what I want to do tomorrow yet. 13, okay. Yep. So you will have your SAT2, okay. So that is a Wednesday, Okay, Wednesday. Okay. And so because there are too many days for revision already, so I will start teaching chapter 4 tomorrow. Okay, please download the one in times, talk about estimation of the area bounded by the curve. So I will base on that and teach. Are you clear? So we have 3 hours. I will try to teach chapter 4. Then after that, you have the weekend to do your revision for SAT2, and Monday and Tuesday, you can ask me again. If not, we are wasting our time. Do you get me? Okay, good. So any question? Okay, look, you still remember your logistic function, correct? Your logistic function is go like that. You better put this in your notes. So the graph for this is like this. Correct? And there is a limiting value. Is y equal to c, am I right? And this point A, okay, I don't put it point A, I put it point B, put it point K. This point K is called the non-stationary inflection point of, okay, I call this FT, okay, of y equal to FT. Right? And we know that the x coordinate for point K is ln A over B. And the y coordinate will be C over 2. Am I right? These are the true facts about any logistic function. So how do I interpret this? This one will be say that at t equal to ln A over B, y equal to ft is increasing at the fastest rate. Because the slope at that point is the steepest. Understand? So this is one way to get, this is for this function, I can just use this formula to get the x coordinate of the inflection point. Correct? But other question, I may not be able to do that because I don't have the formula. So if other question, I don't have the formula and yet I need to find the time or the situation where the function is increasing or decreasing at the fastest rate. So I must use by the help of I use GC to help me. So I use GC to help me. I key in my Y1 as my fx. So I key in my Y2 as my Y1 derivative. Right? Then after that, I will only plot the Y2 graph. Okay, why I want to plot the Y2 graph? The reason is like that. Like for example, in this case, I plot the Y2 graph. I will get a graph which look like this. And this is ln A over B. So this is y equal to f prime x, f prime t in this case. So I know some true facts. Okay, huh? So this is some true fact that you have to jot down. Like for this case, I'm not going to use a graph because plot graph is another hassle. Am I right? Since I got the formula, I just apply the formula. So if in the case I don't have, it's not like this function, so I'm going to use this method. So now I know that the x coordinate of the stationary point of which graph? Of y equal to f prime x graph is the x coordinate of the inflection point of y equal to fx. Are you clear? Because of this relationship, you can get the x coordinate of the inflection point of fx from that of the f prime x. From fx itself, you can't. Are you clear? So if any cases other than you got the formula, no formula, okay. If got formula, you straight away use a formula. If not, then you use your GC, sketch the derivative graph, find the x coordinate of the stationary point. Stationary point coordinates you can get from your GC, am I right? Okay, so based on that, if any question asked for a function increasing or decreasing at the fastest rate, then you can use your GC. You don't have to go for second derivative. Are you clear? So take note, definitely there will be one question like that. Okay, I need your attention, class. If whatever in your graphic calculator, they appear things like that, for example, they give you the answer, your graphic calculator, your GC, give you the answer like that, negative 1.762 e to the power of negative 7. Okay, this is read as negative 1.762, e means 10 to the power of negative 7. It means negative 0.70. 1, 2, 3, 4, 5, 6. So this one you can say approximately 0. Are you clear? So as long as you have number that is shown by your graphic calculator, especially when you talk about local maximum, if you appear as e to the power of negative 4 onward, correct? You can just approximate it equal to 0 already. Are you clear? So take notes of that point. Like for example, the graphic calculator give you 1.23 times 10 to the power of e to the power of negative 5. So this will be written as 0.1234. 1, 2, 3. So it's approximately 0. Yeah? Clear? That is the meaning of E. Thank you.